Rounding whole numbers. So rounding is actually in the same section where you're learning place value. Place value is very important. There are many skills that come from place value. Rounding is one of them. Rounding will be tested on the GED math test. Rounding is also used in other parts or other places in the test, for instance, maybe social studies, maybe science. But rounding is definitely something that we do every day. And most people understand rounding as a large concept. For instance, if I show you the number 47, and if I just asked you to round the number 47, most people were going to say, well, if I rounded it, I'm going to say the number 50. Now, technically, I didn't give them any instruction on how to round or what to do. Most people have an idea of rounding. So let's talk about that technical aspect of rounding so that when we start dealing with different numbers, larger numbers that have more digits, and also when I'm asked to round to a specific place value, that I know the technical rules of rounding. Okay, here we go. So when it comes to rounding, there is a technical rule. For instance, if I go back to this number 47 and I ask, and I'm being asked, round this number to the nearest 10. This is exactly the way the GED test is going to talk about rounding. Again, they're telling me to round this number to the nearest 10. So I have to know a few things about this. The first thing I have to know is I have to understand the place value 10. And the 10 place value is the second spot. So for instance, it's the 4. Normally, what I'll tell students to do is the first thing in rounding is to underline the place value that they're asking you to round to. So if they're asking you to round to the 10, I tell students underline the place value that they're asking you to round to. By doing that, you're giving yourself a few clues because your eyes are going to start to move around when you do something like this. It's reminding you that this number that I'm underlined is either going to stay a 4 or become a 5. And I'm going to make that decision uh, by the number that's directly behind this number. So most people will say, Darren, so what do I do? What about that number? It's 5, right? And I'm going to say, well, what do you say? Some people say, is it great? Is that number greater than 5? Now, by saying greater than 5, you're actually not saying the rule correctly because greater than 5 is not talking about 5. It's talking about the number 6. You're not including 5. So you have to say, is the number behind the 4 5 or greater? I have to remind myself that the number behind the 4 can also be a 5. And if it's 5, 6, 7, 8, or 9, then I'm going to round the underlined digit up to the next value, which would be a 5. So I look behind my 4, I say, okay, or again, let's repeat this process. They tell me to round to the nearest 10. My first step is to underline the value that's in the 10 spot, and that number is a 4. Now, it's not that digit that tells me whether to round up or down. It's the number directly behind. I do underline this digit because it reminds me this number is going to stay a 4 or become a 5 based on the number directly behind it. When I look at the number directly behind it, I also ask myself or remind myself about the rule. Is that number 5 or greater? If that number is 5 or greater, for instance, the number 7 definitely is, then it means that I'm going to be rounding the 4 up to the next digit, which is a 5. So my number is going to be larger. Everything that's behind the underlined digit will become a 0. And this is true of any rounding, whether I am rounding up to the next value, for instance, here where 4 is becoming 5 or 47 is rounding to 50, or if I'm rounding down, where, like, for instance, 43 rounded to the nearest 10 would be 40. Whenever you do this, the digits behind the rounded value will always become zeros. Always. Let's try it again. And instead of using just 2 digits, let's do something with a few more digits. For instance, let's do something rounded to the nearest 1,000. I'm going to put another example up here. This is where people start to make mistakes. So let's add a few more digits and try this rounding again. Again, we're going to follow the same rules. So again, the GD test will tell me round to the nearest thousand. So again, they're telling me the place value to round to. So step one, I want to underline the value that's in the thousands position. And the number that's in the 1000s position right now is this 4. So I underline it. I want to make sure to do that always because my eyes are going to start moving around. I don't want to lose focus and say, hey, that's the number that's either going to stay a 4 or become a 5 based on what's behind it. Now I look directly behind that number. Now you'll notice there's 3 digits behind that number, but you don't look at all 3 digits. It's the number directly to the right. Whatever number that is the value you should be looking at. Okay. So I'm looking at the number directly to the right of that underlined 4, and I see a 4. Now I ask myself the same rule as before. Is this number 5 or greater? Now, in this situation, the number is not 4 or larger. I'm sorry, 5 or larger. It's actually 4. It's below 5. So is this number 5 or greater? The answer is no. So what's going to happen in this situation is the 4 is going to remain a 4. It is not going to be rounded up to a 5. Everything that's behind the 4 will now turn to a 0. So this 4 is going to be a 0, this 9 will be a 0, and this other 9 will be a 0. Another way to say this is this. Is 4,499 closer to 5,000 or closer to 4,000? And if you looked at this and you'd say, well, Darren, it is $1 away. I mean, if this was 5,000, if this was 4,500, then I would definitely round up. But it's not that. So you would say this number is closer to 4,000 than it is 5,000. Let's try again. Now, when I'm doing this next one, I'm going to let you pause. I'm going to go ahead and tell you what to do, but I'm going to ask you to pause the video, try rounding it, and then restart the video to see if you and I came up with the same answer. Okay, here we go. I'm going to put another number up here. I'm going to change this number, okay, because it's only fair that we do that. Okay. And now, again, you have to wait to be told where to round to. Okay. I'm going to tell you to round this number to the nearest 100. Round this number to the nearest 100. Now, again, you should go ahead and pause the video and try this, rounding this number to the nearest 100, and then restart the video and see if we come up with the same number. Okay, so if you've paused the video, I'm going to go ahead and go through the steps again and make sure that we've come up with the same number. So step number one, because I asked you to round to the nearest 100, you should underline the number that's in the 100 position, and that number is a 3. That's the value that's either going to stay the same or increase to the next digit. That's going to stay at 3 or increase to 4 based on what's behind it. I draw a little arrow. You should draw an arrow, especially in the beginning, to remind yourself that you're looking directly behind that underlined digit. That's the number you need to make the decision on. Okay, I ask the same question I always ask. Is this number 5 or greater? And you would say, well, yeah, 9 is larger than 5. So yes, 9 is larger than 5. So yes, I am going to round the 3 up to the next digit, which become a 4. That is true. Now, again, everything behind that rounded digit will become a 0, just as before. Now, here's something that kind of interesting. What about the digits in front? Those have to remain the same. I have to put 159,000 in front of it. I didn't change those numbers because again, let me read it to you differently and maybe it'll start to make sense of why that didn't change. If I give you the number 159,392, and I ask you the question, is this number closer to 159,400 or 159,300? By asking you that situation, it would be easier to understand to saying the answer. Well, yeah, that number is closer to 1,000. I'm sorry, 159,400, not 300. That's why those other digits don't change. And again, they don't change because I have only asked you to round to the nearest hundred, nowhere else. Now, there is another situation that may come up in your rounding that kind of will throw people off sometimes. Let me show you that situation. That situation is dealing with sometimes with nines. Let me show you. I'm going to put the number 95 up here. 95. And I'm going to ask you, let's go ahead and just do some rounding. Hey, let's round this number to the nearest 10. So again, it's still the same situation as before. Nothing has really changed for me. I'm just have the number 95 and I'm being asked around to the nearest 10. So when I look at this, I say, well, the 9 is in the 10 spot. I underline it just as before. Nothing's changed. I look directly behind because the number behind it will tell me whether that 9 is going to stay a 9 or increase to the next digit. But the next digit is 10. We'll talk about that in a second. Okay, so I look at the number directly behind and I ask the same question. Is this number 5 or greater? And I would say yes, this number is 5 or greater. So it means that the 9, the underlying digit, will increase to a 10. Okay, now here's the thing. The number 10, you don't stick it in one spot like this. It doesn't work like that. This new answer is not 10. So what's going to happen here is something old school. I don't know if many people remember this. This is called carryover. When you first learned about addition, let me go ahead and demonstrate it again for you. Okay. What it means is that when I add the number, if I'm adding to the next amount, if I add another single to this $9 bill, then I'm gonna exchange it for a $10 bill, one $10 bill. So what happens is that the number 10 looks like this sometimes. Some people will say, well, this zero is going to stay and the one is going to carry over to the next spot. So this number is closer to 100, not 90. Let me repeat this again to you. If I showed you the number 95 and I asked you just the question, hey, is the number 95 closer to 90 or 100? You would say 100. So let's go through this one more time. I'm going to give you another chance to look at this. Let me go ahead and erase a little bit here and let's do it again. This time I'm going to do it with a few more nines because those are the ones that sometimes give students trouble. So let's go ahead and do this one more time. I'm going to give you the number 996, whatever. It doesn't really matter. Okay. Okay. So again, I have my number 996. I'm going to round it to the nearest 10. Okay. So if I rounding to the nearest 10, I want to underline that digit, and that digit is this digit, which is in the 10 spot. I'm going to look directly behind to ask myself whether that's going to stay at 9 or increase to the next value, which is 10. Okay, I'm going to ask the same question. Is the number directly behind 5 or greater? So I look behind, I say, yeah, that number is a 6. It is greater than 5. So it means that 9 is going to increase to the next number, which is 10. Now here's the situation. Again, by adding 1 to 9, it becomes 10. Well, here's the thing. The 0 stays and the 1 carries over to the next place value. Now, by doing that, I'll say, okay, well, I also have this 1 that I'm adding to this value, which is a 9. And 9 plus 1, again, same situation, is 10. So what will end up happening is that the 0 will stay and the 1 will carry over to the next place value. Carryover can be quite weird at looking at it like this. Let me go back and repeat myself. So again, if I start with the same number, 996, and I ask you, hey, is this number closer to 1000 or 990? You're going to say it's closer to 1000. And the reason for that is that the 6, again, is 5 or greater. Let me demonstrate one more way, 'cause sometimes this can be quite confusing for students. I'm going to go ahead and give you the numbers 99. And let's go through old school math one more time, where it's 99 plus 1. Now, this is again old school math. And if you don't remember this, it's probably because this is taught like in first grade. And once you start doing carryover, you practice it once or twice, and then after that, you're using calculators, you're using other things, and we kind of forget the idea of what carryover means. So let's go over and do it one more time. So 9 plus 1, again, I'm adding these digits first. 9 plus 1 is 10. Now this is where I'll say the 0 stays and the 1 carries over, plus 1. This is a carryover. This is what it looked like when you were back in first grade, if you remember that. So again, 1 plus 9, again, is 10. The 0 stay, and the 1 carries over, again, to the next place value, which will drop right there. So again, is 99 closer to 90 or 100? You would say, well, 99 is closer to 100. And this is how we do it. So again, practicing your rounding is important. It's a skill that you will use quite often on the GD math test, maybe 3 to 4 times. Now, will they ask you just to round? The answer is no. Rounding is going to show up in different concepts. For instance, maybe you've been given a math problem, a worded math problem, and you're solving. And then again, the final step will be round that number to the nearest 10,000, round that number to the nearest 10, whatever the situation is. But give it a shot, continue to practice. That's the only way that this is going to get a little bit better.